All right, today we're going to hack our senses a little bit. We're diving into this little white dome device, the passive infrared or PIR motion sensor. We're going to cover exactly how it works, how to wire it up to an ESP32, and the code you need to get your first motion sensing project off the ground. Let's get into it.
You know, what's so wild about this sensor is that it doesn't actually see movement in the way we do. Nope. It's designed to see the invisible. It detects infrared radiation, basically the heat that all living things give off. You, me, your dog, we're all glowing from this sensor's point of view. And when that heat signature moves, bam, the sensor triggers. So here's the game plan. First, we'll get properly introduced to our sensor. Then, we'll get our hands dirty with the wiring. After that, we'll jump into the code to program the ESP32's brain. Then, and this is a big one, we'll look at the different trigger modes. And finally, we'll wrap up with some pro tips so you can avoid the common pitfalls. Okay, first things first, let's get familiar with the star of our show, the super popular and really versatile HC-SR501 PIR sensor. Now that white dome on the front, it's not just for looks. That's a special kind of lens, a Fresnel lens, and its job is to give the sensor a really wide field of view, about 120 degrees. Then, if you flip it over, you see the brains of the operation. You've got your 3 pins for connecting everything, and those 2 little orange dials, those let you tweak the sensitivity and timing. And you know, getting this thing hooked up is incredibly simple. It all boils down to just these 3 pins. You've got VCC for power. We're going to use 5 volts from the ESP32. You've got GND for your ground connection, and then there's the out pin. That's the important one. It's what sends the signal to our ESP32. It goes high when it sees motion and drops back to low when things are still. Simple as that.
All right, let's make the magic happen. Time to connect these 2 devices and get them talking to each other. It's just a simple 3-wire job.
Okay, grab your wires. First, you're going to connect the VCC pin on the sensor right over to the 5V pin on your ESP32. Easy enough. Next, take the sensor's GND pin and connect it to any GND pin you've got on the ESP32. And last, the signal wire. Connect the out pin from the sensor to a digital GPIO pin on the ESP32. We're using GPIO 14 here, but hey, you could use a different one if you wanted to.
And here it is, the final result. See? Clean and simple. The red wire is power, VCC to 5V. The black one is ground, GND to GND. And that third wire is our data line, linking the sensor's out pin right to GPIO 14 on the board. And just like that, the hardware part is done. With our circuit all wired up, it's time to give it a brain. We're going to use the Arduino IDE to tell the ESP32 exactly how to understand what our new sensor is telling it.
First up, a little bit of housekeeping. We use this #define command to give a name, PIR pin, to the number 14. Why? Well, it just makes the code way easier to read. Instead of seeing the number 14 everywhere, we see a name that tells us exactly what it is. Super helpful if you ever want to change the pin later.
Next, we've got the setup function. Now this part only runs once, right when the ESP32 boots up. The first line, serial begin, just opens up the communication channel to our computer so we can see what's going on. Then, pin mode, PIR pin, input, tells the ESP32, hey, that pin 14, you're going to be listening for a signal from the sensor on that pin.
Now, the loop function. This is where the real action is. This code runs over and over and over again. Inside, digital read checks the voltage on our pen. If it's high, the code spits out motion detected to your serial monitor. If it's low, you'll see no motion detected. That's it. The board just keeps checking constantly.
Okay, let's pause on the code for a second, because we have to talk about a really critical hardware setting. This next choice is a total game changer, and it completely alters how the sensor behaves, especially if there's continuous motion. You absolutely have to understand these 2 modes. Think of single trigger mode as a doorbell. You press it, it rings once, and that's it, even if you keep your finger on the button. Repeat trigger mode is more like a motion-activated floodlight. It turns on when you walk by, and it stays on as long as you're moving around in the yard. It only turns off after you've left.
So how do you pick one? Well, it's not in the code. You actually have to physically move this little yellow jumper on the back of the sensor. You see the L and the H? Set it to L for single trigger, the doorbell. Move it over to H for repeat trigger, the floodlight. Which one you pick depends entirely on what your project needs to do.
Let's look at this timeline for single trigger mode. So motion happens, and the output goes high for whatever time you've set with the dial. But here's the key thing. After that time is up, the output goes low even if you're still waving your arms around. Then, the sensor goes into a blocked period for a few seconds where it's totally blind.
It won't trigger again until that period is over.
Now, compare that to repeatable mode. As this quote totally nails it, every single time the sensor detects more motion, it resets its own timer. So if you set the delay to, say, 30 seconds, and you just keep moving around, that output will stay high the entire time. It only goes low 30 seconds after the very last bit of motion it saw. This is perfect for things like keeping the lights on in a room while someone is inside.
All right, before we wrap up, let's cover a few common traps. Knowing these things up front is going to save you a ton of time and debugging headaches. Trust me. The number one absolute biggest mistake people make? Not being patient. When you first power this sensor on, it needs a good 30 to 60 seconds to calibrate itself, to get its bearings. During that time, it might go off randomly. So just plug it in and walk away. Give it a minute to warm up before you start testing anything. Also, be smart about where you put it. Keep it away from things that cause sudden temperature changes, like an AC vent or a window with direct sunlight, because that can set it off. Make sure you're feeding it 5 volts, not 3.3. And hey, keep that white dome clean. Dust can mess with its vision. And finally, please double-check that you've set the right trigger mode for your project. So, there you have it. You now have the power to make your project see the invisible world of heat and motion around us. So the only question left is, what are you going to create? A security system? An automatic light? Maybe some interactive art that comes to life when people walk by? The possibilities are pretty much endless. Go make something awesome.